No, I don't think so. Why is it annoying? No, I like it in there because it pings people so that they know class happens if they forget. Changing it. Oh, I have to update it for every class. Maybe that's what I meant. It's, I have it show the particular section that we're in. Hey, new follower. Or somebody with a new username, one of the two. Alright. Fancy emotes. Oh no, water everywhere. Oh, it's Monday and it's already a day. Alright, water goes all the way over here. Alright, how was everybody's weekend? Hey, it's time to go. YouTube.
Professor Patrick. Professor? Professor Patrick? Don't mind him. You know how interns are.
Where is Miss Cheeks?
She should be back any moment.
I thought she ran away because she couldn't invent anything.
Patrick?
It's Mr. Dr. Professor Patrick to you.
1 second. I gotta grab something here. So, my sister, in her eminent wisdom and love of SpongeBob, got me a plaque, which actually mimics that for my desk when I have an office, or when I go back into the office. Good meme. Okay, so I went through and you don't need to see that yet because I don't know if we're getting to that. I went through and I graded all your homework, so you should have feedback from that. I sent it last night, and if you should be able to see the feedback. So I wrote something on everybody's. I copy and pasted all of the team-based stuff into each team members, since it wasn't a team submission, obviously. But if you have any questions on the feedback, please let me know. There's a couple things I wanted to talk about. So as long as you followed the instructions, you pretty much got full points. It was kind of hard to, unless you missed a little thing, like I know one team forgot to add links to their usernames. Pretty much everybody did well. A lot of people didn't submit, so that's something we can talk about separately. If you did the extra credit, basically set up GitHub pages, so you got some points your way if you went way above and beyond and set up something that looked really stunning, you got the full amount. So good job to those of you that got going with GitHub pages. Hopefully you realized how easy it actually is. The pages are all done in Markdown, so you're all going to have to do that anyway in the near future. So the extra credit was to get a kick and get you going with that. The other thing with the GitHub pages, which if you're struggling and you didn't ask, you have to make your repost public, otherwise it asks you to pay for it. So those of you that kind of went through the process discovered that, but it's one of those features, I suppose. And the other thing, there was a handful of groups which actually didn't do the project proposal. I don't remember how many in this section versus the other one, but there was, I want to say 4 or 5 teams that didn't actually write the proposal. Normally, I would just take the 50 points off and we'd move on and you would learn a valuable lesson. But since we're in crazy times, you will have a chance to make those points back up in the very, very near future. So if you notice you got 100 out of 150, that's probably because either A, you didn't do the proposal, or B, you put it somewhere I wasn't expecting it to be. So if that's the case, please let me know. Other announcements. So Wednesday we are going to do a out of class lab. I have my last conference of the year, hopefully, that I have to go to on Wednesday. So we won't have class. I'll send out an announcement, but you'll have something to do during the time, basically. So be on the lookout for an email forthcoming. Any questions so far at all? Your next homework's basically going to be, I'll put it up tomorrow. Wednesday's class will kick off your next homework, and that'll lead right into your midterm stuff since that's kind of coming up soon-ish as well. But anybody questions, comments, anything like that? Thank you all of you for keeping up with this stuff on Blackboard, the assignments and in-class assignments and all of that. None here. Awesome. And like I said, if just to reiterate the point, if you are concerned or you're struggling, please reach out to me because I know this is a hard time for everybody. I am more than happy to chat if we need to. So what we're going to talk about today are use cases. So we did a initial look at them last time, right? I kind of walked you through my little, well, sorry, this is the pretty diagram from the afternoon class, which I should have done for the morning class. My tablet kind of spazzed out and didn't make for good diagrams. If I had a whiteboard behind me, or we're in class, it would probably be just as bad anyway, because I've got awful handwriting. But this is kind of what I was trying to present. I'm just going to use, so this is actually the draw.io. It's now diagrams.net. But this is that tool that I have in Blackboard, which is very helpful for doing any kind of UML diagramming. They have all of your particular objects that you need. So we see like class diagram stuff, component diagram stuff, class diagram stuff. So it's all in here and it's all basically free. You can even, I think, hook it into Google Docs if you want. But this is what I was trying to demonstrate, was having a interaction for a game. So here my player has to start and load the game. We have to initialize the game. We have to generate levels. So basically we have actors, whether they're people, whether they're systems, they all have an interaction. We also have relationships that we're going to talk about today as well. So the whole point of today is to delve into how you can actually make these and why you would want to make them. And then after we get past the visual syntax, we also have some verbal stuff we have to write out as well. Basically, each one of these use case diagrams gets it's not a card, it's a little bit more in depth, but basically you're going to spell out exactly what everything means. So there's a little bit more prose behind it. I should probably get out of this because I'm not playing anymore. I guess I will say this too. I did want to mention when I was reading through all of your term project descriptions, I thought they were all pretty good. Some of you were going a little bit above and beyond, but those teams tended to have a lot more team members, so we'll see how it goes. Just keep in mind looking for a functioning prototype. You don't have to have a polished, ready to go in the App Store kind of thing. Focus is going to be on the software engineering process, and the demo is going to be the cool thing you actually show how these all flow into it. All right, so without further ado, let's talk about use cases. Now, what are these diagrams that I keep telling you about, and why do we care? All right, so you can either hyphenate them or not hyphenate them. It's your preference. depending on whether I'm repurposing some of Dr. DeVries' slides or not. He likes hyphens, and I just got sick of rewording everything, and I just left them on. But what a use case does is it's capturing some unique function. And when we say a function, it can be a kind of nebulous task. All right, so it's very high level. Consider this like a goal where you're trying to encompass the entirety of this interaction, whatever it is. All right, so here are some examples at the bottom. Let's say that you're making a word processing software suite, right? You're making TLX use case. Nice. Um, where's it going? So you're making in addition to LibreOffice, because we'll pick the open source word processing software, right? You want to do everything that it takes to format a document. That is the use case. When you're doing word processing, obviously you have to handle fonts, you have to handle sizes, paragraph styles, page settings, right? All that fun stuff. That is all very detailed, right? The high level is we have to format a document. That is a use case. Nice emoji or nice emotes formatting there. All right, so we need to format something. We may need to request an elevator. So you're writing elevator software, right? And if you're taking a algorithms course, you probably go through some of the elevator scheduling algorithms, which are fun thought experiments. How do you minimize people's annoyance with the elevator when you push the button and you're sitting there waiting for 20 minutes? But you're not writing a use case for, deploy this particular algorithm. It's we just want to request the elevator, or the elevator may be moving, right? So going up, going down. We're looking at high level goals here. It should be discrete as well, right? So use cases should not be, there shouldn't be any functionality in one use case embedded in another. You should be able to describe the entirety of this feature in one single, very small bit of language. One other thing too, the size of this function, it can differ. So request an elevator is obviously a very high level goal, or format a document is a very high level goal. If you want to go deeper, right, you want to have font formatting capabilities. So specify font size or specify font. That could be a goal, but then all of your other, use cases will be at a similar level of precision, right? So a similar level of detail. The key here is to be consistent, right? So you don't want one massive high level goal and then a whole bunch of very, very detailed goals. They should all be approximately the same. So that is effectively what a use case is. We're capturing functions or capturing ideas. Question for you all, and I've got a slide here on the next page to get some chatter going. How do you think we discover these use cases? All right, so how do we elicit them? Keep in mind we probably have already gone through the requirements elicitation process. So we have our SRS. If we're going more of a waterfall type approach. If we're doing something more agile, we might be doing this in parallel. But how do we find these things, do you think? So let's say we have our users, we have our requirements document. How do we get use cases out of that? Ask the customer what they want. Yeah, right? So we have a user. What would you like to see? Beta testing, publish a prototype and generate use cases from it. Sure, absolutely. Functional, non-functional requirements. Yep. So let's start with the first one. While the response, oops, sorry. I keep forgetting I can't highlight, and then when I do that, it skips ahead. So you ask the customer what they want. They're not necessarily going to give you detailed requirements when you talk to them, right? I want a search function. I want a text box that allows me to input user data. Okay, so I need a data entry form. Testing surveys. Yep. So beta testing, publish a prototype and generate use cases from that. So start with a prototype and then figure out what the use cases for that are. So we're doing it in parallel. Absolutely. Usability between you and the customer. Testing and surveys. Testing users run the software and see what they do from what the system is capable of. Yeah, so these are all actually good answers. So you might generate a prototype. Sure. So let's pick on one of this first one here, publish a prototype, and then surveys, testing with users, testing the system. We can give them a blank slate, maybe with some basic ideas of what we think, and then what would you like from this? And we're still asking the customer, right? Or from the functional, non-functional requirements. So we can see a list of all the detailed specs, and then we can lump them together. Right, if we're defining a user registration system, we'll have a bunch of requirements specifying, what fields are necessary. We'll specify what kind of validation we have to perform, what kind of transformations have to occur to put it into our backend database, right? Do we have to hash the password? Do we have to have character limits or email complexity? All of these things can be requirements, and that can be user login form or provide user login or something like that, right? So yeah, these are all good. Key here is that we're taking what we know from the detailed level and making high-level diagrams. And again, the question that you may or may not be thinking of, I'm thinking of it, what's the point of all this effort? Right? We already have the specs. Do we need more? And again, the question that you have to ask is what type of communication are you planning on doing? Right? When you talk with the customer, when you talk with your engineers, when you speak with management, do you want to show them the big requirements spec? Or do you want to show them the high level use case diagrams where it's very easily digestible and very quick to communicate? And it kind of one of the points that I want to mention here is that if you're going to be sitting down in a meeting, whether it's in a business setting or with your team, you don't want to bring requirements 1 through 5, 20 to 30, 34, 35, and then say, this is all of our system here, right? It's a lot more difficult to parse that out. But if you have a very simple use case diagram, okay, this makes sense. And then when we need more detail, we go to the requirements. And we will link requirements to these use cases as well. Okay, so all good so far, which, everybody seems to be on board, which is good. I assume, based on the slidey responses. So let's consider document formatting as our use case that we're trying to figure out here. When we're defining use cases, we have the notion of goals versus interactions, and this will become a little bit more clear when we go more into the details here. So we have, let's see, 3 things and 2 things. So we want to do our document formatting. We can define a style, we can change a style, we can copy style. So that's where you have your font and your paragraphs kind of baked together where it is a style. Or like you're defining a heading. Like if you go into Word, you can click heading. That'd be changing a style, right? When we look at these bullets here, these are very detailed, right? So there is some kind of a close technical implementation. Here, let's compare these very detailed kind of implementation specific goals here to just format a document or ensure 2 documents are consistent. Difference is that these are user goals. Okay, so a goal is something to be achieved. These are interactions. All right, so this is going to be something that either a user or a system, basically an actor, is doing to the system to achieve the goal of blah, right? So user goal, I want to format a document. User interaction, define a style or change a style. They're tied together here, which we can see, but we have to interact to make this happen. So a little bit of a slight difference. And again, depending on the level of granularity that you're trying to model out, this could all be debatable, right? If we go back here, just to kind of play devil's advocate, let's say define a style. Well, clearly that's a goal, right? I need to define styles. All right, but you may have interactions, what goes into defining a style. So you'll have something even more detailed to describe that. Point is, a goal tends to be a little higher level interactions, how you're achieving that goal. Okay, so why do I care and why should you care? We have to understand what all of our goals and what all of our interactions are. Otherwise, we're not going to know, again, graphically, what our system is doing. And these interactions are going to go into your relationships that we have to define, right? So start thinking of how actors interact with our use cases, right? That diagram I showed you at the beginning there with my game being loaded and saved and started and all that. The interactions are going to get us to, well, how do you load a game, right? This is also going to feed into how our activity diagrams are described, how our sequences are described. So basically, flow of information, flow of activity, again, how your program is structured when you work through it. All right, so we have a place for these. Generally, what we care about is we are going to try and figure out what the high-level goals are, and then we'll refine them into interactions. Could be one, could be several, could be many. Basically, we're just trying to capture these into a formal diagram here. Okay, so now finally, we are going to actually talk about the syntax of the diagram. And again, I want to remind you here, I'm not necessarily expecting you to be perfect experts in UML version 2. Whatever we're at right now, but you should at least be aware of what all of the symbols mean and how to use them. You don't necessarily have to be perfect, but you should be able to communicate with me what your use case diagram means. So we have actors, and now these are going to be either systems or people where they interact in some fashion. So we're going to specify our use cases, and then we're going to specify who needs to interact with that use case. So to format a document, you need a user, and you need like a word processing software, right? So those would be two actors. One is a person, one is a system. They both are going to interact in some fashion. Keyword here is that these actors are external to the system. Now, we're going to talk about boundaries in a moment. When you define a use case diagram, you're very perfectly encapsulating what these use cases are, right? What these high-level goals are. And depending on where that boundary is drawn, you may have actors that are external, right? So a person is clearly external to the system. But if you draw your boundary a little bit more broadly, you could technically encompass that word processing software. Then your goals would be a lot higher level. So it's going to be very important to figure out where the boundaries are, and we'll talk about that momentarily. But the key here is that actors need to be external to whatever you're modeling currently. Right, so if I go all the way back to the beginning here, sorry not to, let me pop forward here. Here we have a clear boundary, so this is kind of what I'm talking about. These actors need to achieve that goal as well. So based on how they interact, it should make that goal achievable, right? So that use case has to be achievable by those actors. If you are missing some functionality or missing some kind of a interaction, that will be very clear, right? So if I'm trying to start a new roguelike game, I'm going to need me, the person kicking it off. I'm going to need the map generator. I'm going to need the game framework to initialize everything else, and probably some other systems as well. If I don't have all of these pieces, I can never generate a random cellular automata type of map where the caves look nice and organic. Or if I'm making a web application, I need a user to enter data, I need a system to validate everything, I need a system to insert it into our database, maybe to look up and see if you're unique or not. These are all going to be external actors. Without these actors, I can't do that. And again, high level, let's try and figure out who is interacting with what system. If I broaden this boundary, okay, maybe these subsystems are encapsulated. It just depends on how you want to represent things to, again, communicate with others. So that's what an actor is. It's going to be a little stick figure. We have our use cases, which is effectively what we've been talking about so far. These are our goals. Okay, they're little ovals with a very short verbiage in them. So usually it's like a verb and a noun is the recommended formatting. So again, goal is bolded here because we care about the goal level with use cases, right? So compare goals to interactions. When we draw use cases, they're generally goals. And again, if you think back a few minutes ago, goals are debatable depending on what your level of granularity is. If you don't know what level of granularity is, that's how detailed you want to get, right? So what level do you want to communicate? These goals should give a result to the actor too. So format a document, it's very clear what we're doing, right? If it's something a little bit too broad, you don't get a result, then it's not really a good use case and we have to go back and look at it. And then we also have connections. We also call them relationships. Basically, how do use cases and actors interact? Right? So if I have a line drawn from an actor to a use case, and again, it's going to look really simple when we flop over to the diagram. Looks like it's just a line, but that line, again, it implies something behind it. You draw a line from a user to a use case, that implies that I am interacting with that in some way, which means you're going to have requirements defining that, which means you're going to have code defining it. So don't want to harp on this too much, but this is basically the constructs that we're looking at here. We can also have use cases connected to each other as well, which we'll talk about soon. All right, so here we have a use case diagram. Well, not, sorry, a handful of use cases. All right, the diagram is coming soon, where we're basically handling loan applications. So this is a kind of a common book example or educational example where we need to be a loan officer. We're using a system to approve or reject loans or handle them in some way. So again, the circles are use cases. The whole thing is a use case diagram. These use cases are not a flow. So you don't see data going in and out. You don't see state machines kind of ticking through. We don't have sequence diagrams in here, right? It is simply a atomic entity. We're going to evaluate the loan application. We will generate a late notice. We will close out the loan. We could also have approve loan or deny loan in here if we wanted to go a little bit more detailed. There is no if credit score good, approve loan in here, right? It's just a entity. This comes later. Things you care about here, again, verb noun combination. So evaluate loan application, close out loan, generate late notice. And if any of you are grammar focused, close out is obviously not a verb in itself. Close is the verb. Then we have would this be close out adverb? Been a while since I've done sentence diagramming, but verb noun effectively is what we're going for. Very, very terse. Now, what do we care about? What's happening? So the goal should be described. If we are talking about an interaction, it should be very clearly described here as well. So we talked about the difference between goals and interactions. Again, depending on your level of detail, we could have handle loan applications as a high-level goal. And then evaluate, close out, generate notice. These could be more interactions as well. All right, so use cases. The entire diagram is going to look like this now. So this is where we get into our actual diagram. You can generate multiple diagrams for your projects. You will be asked to generate use case diagrams very, very soon. But these should all effectively be unique ideas here. you can reuse use cases depending on your particular diagram, but we may have different, sorry, the idea behind the whole diagram should be effectively unique. So here we're talking about a point of sale system for, if I'm going to a store, obviously. So buy item, login, refund purchased item. We would have another use case diagram for managing inventory or handling our web interface for our store. We can have use cases be similar, but the intent of the diagram should be unique. All right, so here we have a person, so customer and a cashier. What do we care about when we're buying stuff? We have to buy the item. The cashier has to log in so that the system knows who approved the purchase, who handled the money, and then maybe we want to handle refunds. In this case, the cashier has to be there. Cashier has to put it in the system. Customer brings their product back. Customer gets a credit back, right? So kind of the inverse of buy item. Again, very high level, very verb noun-ish. Buy item, log in. It's very terse. We know exactly what's happening. We know who is involved with what, and we know the exact boundary here. Where's the bubble for where the customer yells at the cashier? Let's see. Can I draw in this? Let's see. It's a good point. Very important points here. So let's add it's just gonna give me a circle. Where's bubble? Oh, that will be an oval. B rate, cashier. POS has a whole new meaning. I like that. I like that it blocked POS. So we need a customer interaction there, and we need a cashier interaction. Don't berate that cashier. Prevent. Cashiers are doing amazing work. Don't berate them. Just kidding. Always treat your cashiers with respect. I am the cashier. Then you are doing a thankless job, and we all appreciate it. Customer is not always right. That's a horrible misconception. That the customer is always right until it's a nuisance on everybody else. Think of our how we feel about users. Users are basically your customers, right? And they're always wrong. Why should it be any different in real life? All right, so here we have our use case diagram. All right, so the boundary hopefully is very clear in why it's important to draw it here. And again, when I say draw it, you're just drawing a box. But the box is encapsulating components of the system here, right? So we're encapsulating goals and interactions. If we have the boundary larger, right, we might have the cashier be a part of this, depending on how these are worded. As it stands, buy item, login, refund purchase system, we don't have any of those like subsystems that I mentioned earlier, right? So there's no like validation, there's no cross-checking inventory or making sure that the user actually purchased the item, right? So if this boundary was a little bit more fine, I suppose, so a little bit more detailed where we're considering it, then we might have our subsystems interacting with some of these bubbles. But as we've drawn it here, very high level, again, very goal-oriented, the only actors are people. And I guess just to give you the what these are actually doing, the boundary is the box here. These are our use cases. Whole thing is a use case diagram. Right, so this is basically just another look at what kind of I mentioned here. So we can also look at it from the perspective, and I'm just realized I'm hiding some text here. Whoops, don't want to do that. I just move, no, stop moving the whole thing. There we go. Let's move me a little bit. So this arrow should be pointing at the use case, but our boundary again is that we can buy an item, we can refund an item. This is what the customer's interactions are. We add in the cashier. The boundary is very clear. This is something that will become very honestly easy with practice. One of the next things I'll have you do is look at some, derive some basic requirements, and then try to derive some use cases from those requirements, and hopefully the notion of where you set your boundaries will kind of come into play. So say that those of you that are doing Unity games, you're going to have artificial intelligence agents. I think one of you are doing like a horror themed game. You're probably going to have enemies running around or scary spookums pop up. There's probably going to be some kind of a system running that. So you might have spook user. There will be an enemy AI pointing to that, right? Then the boundary would be player interaction or something of that nature. Ah, absolutely. It's a nice little zombie emote there. Cool. User is woke. There you go. It's not a horror game, it's an alarm system. All right, so this is another view just to kind of show you what's going on, because if you look at the internet, there are a ton of UML resources out there. So it's always good to see multiple viewpoints of it. I've actually got a link here if you want a little bit more detail. Somebody wrote a Medium article, which means clearly it's professionally prepared, but this one was pretty decent if you want to get a little bit more about it. So here we have our actors, 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 actors. Our relationships are all these lines. Boundary is the box. There is a notion of private in here as well. So when we start talking about private things and public things, that may or may not be something you want to define in your use case diagram, but basically use cases will be encapsulated by this boundary, for instance. So baggage, so we could consider that a person. Do I have a, okay. I just want to make sure I've got another example here with an actual system. So one other example, and this one's a little bit more detailed, and we're getting into some more advanced syntax here, is that we have a trading system. Okay, so this is a lot larger. So it still might be a point of sale. However, we are now broadening the scope of our system. Okay, so we don't just have a customer and a cashier. Now we have, well, a salesperson on the floor, but we also have accounting systems. We have somebody doing trading on the back end. We have, somebody on the stock market with their little ticket, want to buy stocks, because clearly that's how stocks work. But we have almost not a flow, but we have a broader view, right? If I want to buy products to be sold on the sales floor, there are all of these people involved. This is honestly almost getting a little bit too complicated for a use case diagram. Generally, you want like 3 to 8 use cases inside, and that's about all it can handle before it gets too complicated. But here you have, again, a broader view of the system. So here we have a trader where they have to figure out what the risk is. Are there any details? Can we get a deal on some product, right? So we are doing trading. We may have a person setting limits. Nobody's attached to this other than this person. This person is only attached to doing the back-end trading. We have a system here. So basically, we may have automated accounts being updated, maybe based on the current stock prices or whatever's going on here. But here's our first look at an actual system. Now, depending on your preference, this can either be a stick figure or it can be a box with actor in brackets. So it would look something kind of like this. I think I've got in here, actually. Yeah. So this is one other way to denote a system. You put actor in this particular syntax, or you have a stick figure. Both are technically valid. I honestly like the stick figure better personally because it's consistent, but I think the newer syntax to use the box. One other thing that's new in here, we have relationships. So to analyze risk to get a price deal, we have to include a valuation. So basically, we're just trying to, in this particular use case diagram, we're assessing value of product, right? So what's the risk? Are there deals? For instance, we may have a bubble valuation or whatever high level detail this is, right? Where we are including that content. Think of your programming concepts where you include another file. You're just bringing in that functionality at basically as a whole, right? Everything that works perfectly well in this model as well. So we can also extend. So let's say we want to capture a deal. However, we may have a use case where we have bought too many things. So to extend means that we basically take this base functionality and we extend it with extra functionality. So let me pop this up here because include versus extend is kind of it's a common idea in object-oriented programming. It's a little bit tricky if you've never done it, but basically include means that we are bringing behavior in and we're using it. Extend means that we are going to basically do this particular functionality, but it's going to be extended with extra features. So it's not just bring in the metric conversion function and use it. We're going to bring in the conversion function and extend it with polar formatting or something, or polar conversion or something like that. So it's almost like a boilerplate and we're adding on to it in a way. So includes and extends definitely has a place in here, especially if you're trying to kind of declutter your diagrams. If you start finding yourself placing a whole lot of bubbles, which are very, very similar, usually it's a good idea to kind of group them together and just break off relationships to that. Do these concepts make sense more or less? Because it's kind of important to the process here. And I actually had this in my diagram as well, I think. Makes perfect sense. The great answer to make the professor just move on. I assume that yeah. But here I had this notion in here as well, right? So if I want to generate a level, I need to include all of the functionality for initializing a state. If I want to load a game, I'm going to actually extend the start game syntax. So I'm going to have maybe do like a function overload or something of that nature, right? Depending on your language. No, that's not what I was doing. I was a student at 1.2. I know how this works. I definitely didn't play RuneScape throughout my entire master's degree program either. My only concern is that diagonal line. Yeah, it's not perfectly symmetric. I apologize for that, but the way I had the slide worded, I had this kind of slanty boy here, so yeah, let's I'll fix that in the next revision. How's that? All right, so should make sense. Now what we're gonna do is I'm going to assume that you can all draw diagrams like this, right? And if you don't exactly get it right away, you will, with practice, it'll make a lot more sense, obviously. So let's take this particular model here and let's actually add some detail to it. So again, here's our point of sale system. And apparently I apologize, but we're picking on Abby today because we get to analyze you, the cashier. But here are the only things that you have to do during the day, clearly. You have to handle customers, you have to log into your system, and then handle refunds. If that's all a cashier had to do, that'd probably be a lot easier of a job, I actually think. So this is what we're going to be considering from here on out. This doesn't actually tell us much other than interactions at this point, right? We have high-level goals. We have how actors relate to the goals, maybe some more details with extend, include, and generalize if we go a little deeper. But from our software process perspective, that's not super helpful. When we take these and we generate a use case description, then we start getting a little bit more useful, honestly. And this would accompany a use case diagram too. So this would be your, here's my use case diagrams, here's my more detail. I would have quit if only I had to deal with customers the entire time. When I was an undergrad, I had a job I was like stocking food for a little cafeteria kind of thing, and they promoted me to cashier. And after one day of being a cashier, I quit. I couldn't do it anymore. I hate dealing with people. Those of you that can handle that are amaze me. Anyway, um, so here we get a little bit more detail about these use cases. So let's look at by item. We have basically a template that we have to fill in here, right? So by item. Who are the actors associated with it? Well, we have a customer and a cashier, right? We see that right here. We see the interactions. The customer may actually initiate the process as well, right? So the customer brings product to the cashier. I am the initiator. This is something that we can define in a description, use case description. So we have a template field for use case, template field for actors, template field for description here. Now we can actually describe what this use case is doing. Customer arrives at checkout with items to purchase, cashier records the purchase items and collects a payment. On completion, the customer leaves with the items. So we take our high-level verb-noun construct and we break it out into the exact steps that are happening. What is the description of this use case? And if you take a different view of this description, you can actually break out, oh, well, here's actually a sequence of activities that has to happen, right? We can take that later and apply it to another diagram. So 3 fields at the start here. Then we add some more detail. So this was kind of your simplistic view, take it to your manager. This is what this use case does, and they're happy, right? For your process, we have to actually use an expanded use case description. So again, use case actors description still needs to be there. What requirements does this cross-reference? This is where we, again, talk about that notion of traceability, where everything connects to everything else. Which requirements inform the by item use case? Is it requirement 1, 2, and 3? Is it requirements 2.1 through 4.1.1? Right? Which requirements is this use case fulfilling? This is where, again, one of those places where we can identify holes in our process. If we have a use case that doesn't match up to any requirement, well, what does that mean? It means our requirements are either missing information or this use case is not necessary. And if it's not necessary, why do we even have it? So this is, again, kind of one of those things where we can go through and verify that our documentation is correct, that our system is correct. Again, sounds horribly drab and boring when we talk about it, but one of the very important parts, just making sure everything links together. We also can add preconditions. So this is the notion that one thing has to happen before something else happens. So cashier must have completed the login use case. Right, let's go back here. Can I buy an item if the cashier is not logged into their terminal? No, because they can't scan it, right? So you don't necessarily see that in the use case diagram here. Otherwise, again, it'd start getting very cluttered with arrows popping every which way. But here in the expanded use case description, login has to be done first. And then we get the notion of ordering and flow and things of that nature. We can also break the description out into an enumerated list to order it. So instead of having a paragraph, which is kind of hard to read through, you can take it and enumerate it. And again, enumeration is a fancy way of saying put bullets in, except they're ordered numbers or letters or whichever your preference is. What happens first? What happens second? What happens third? And we're breaking it out into more and more detail. And one of the things that I want to leave you with today, since we're pretty much here at the end, is consider how you can use these in your term projects. You're going to be forced to use it because it's software engineering class and we all have to do our use case diagrams to keep your professor happy. But keep in mind that as you work through your team meetings, again, having this kind of high-level description of what you want to do is a great way to make sure everybody's on the same page. Right? I'm reading through some of your Discord chats just to make sure that you don't need any help or advice or anything like that, but I'm seeing people talking about, hey, let's talk about this feature, this feature, this feature. And if you start to capture these in use case diagrams, then it's very easy to see, maybe who wants to work on which aspect, maybe which features would be a little bit too much for this semester, but be great if you want to continue on with it. Or are there any redundancies that you can combine and or get rid of, right? So just to kind of summarize here, again, requirements is very, very difficult. And doing use cases can actually help simplify things for you mentally. Right, so figure out who the users are, what systems you're going to need, what functions your system has to provide. Depending on your level of granularity, you can get a really good feel for interactions, things of that nature. Don't rule out that time spent doing requirements and early modeling is wasted, right? This is one of the most important parts of the process. And I'm going to keep coming back to this point. The coding is strictly a mechanical process, right? Once you learn how to code, pick your favorite approach for writing algorithms and all that, you can hammer it out, right? The mental exercise is always going to be the harder part. So that is it for today, and we hit time pretty much perfectly, which is good. Let me know if you have any questions here in the chat before we end. Again, we will not have a class stream on Wednesday. I will be at a virtual conference. I'll still try to hold my office hours, but you'll have an out-of-class assignment to work on, and it will most likely be team-based so that you can all work together, maybe have forced meeting minute times as well, something of that nature. What is the conference on? It is search-based software engineering. So basically, some of these horribly boring topics to most people, and I apply stuff like genetic algorithms to figure out how to automatically handle stuff like this. My presentation is actually on using Raspberry Pis to run search algorithms. So the idea would be that I run a genetic algorithm on this to figure out which requirements are useful at runtime or something like that. Fun. That's fun. Fun for me. I quite enjoy this kind of stuff. So the thing that's really cool, and not to keep you all too late, but where these requirements and all that get really interesting for me, is how you can actually apply them to systems as they run, measure performance, and you start tweaking requirements, and then you start seeing the system do better or worse just by itself. That to me is fascinating. Like I was a software engineer for a long time, and I hated doing the quality side, so the requirements and the validation, all that I hated it. And then I went into research, and I started seeing how these things can actually impact the system. I was considering getting an Arduino kit too. I did get, so I bought one of these recently. So this is a Pi 4 with a aluminum case to cool it down. This thing is a beefy boy. It can do a lot more than the Pi 3 can. It's a little more expensive though. But yeah, anybody ever wants to talk research in software engineering, I'm always happy to chat about that. Don't remember which one was the monitor now. Arduino. Yeah, for some reason Arduino I never got into yet, even though that would be something I'm interested in. I tried a BeagleBone several years ago, but I always had issues with it. It kept like falling asleep on me. Yeah, let's make our own CPU. Hey, there you go. Lots of cool stuff you can do with these. Yeah, the only thing I miss about being on the east side of the state, I don't know if any of you have ever heard of Micro Center. It's basically like a gigantic Radio Shack. It's like a Best Buy or a Circuit City for just components. Oh, it's so cool. Like I would walk in there and I would just get lost. They have all the switches, all the components. You can build your own arcade cabinets. Yeah, it was the one down in the Troy area. Yeah, fun stuff. Anyway, I will see you all on Friday. Yeah, there's one in it's I don't think it's Troy, is it? It's I used to play hockey out that way in Troy. So I'd always pop by Micro Center before a game. Madison Heights, that's where it is. Oh god. Yep, close enough. Yeah, there needs to be one of these over here because I would just go and hang out. There we go. Way down here. Too bad, not bad. Too many heights. Absolutely. Alrighty. Well, I've kept you all long enough, so I'll start starting a few if you have any questions. Um, yeah, I could go on for days. I didn't even know about Micro Center until like the past couple years, but awesome. Grand Rapids Heights. All right, I will see you all on Friday. Look for an announcement popping in tomorrow to get you set up for Wednesday. You all as well. Goodbye, everybody.